So you will learn how to factor trinomials where we have a coefficient of x squared that is greater than 1. There are two methods to use when factoring these types of trinomials. This video will show you method number 1, which is using trial and error. First, let's discuss what we sometimes need to do when we're factoring a trinomial that has an a value of greater than 1. Sometimes we need to look for what is called the greatest common factor, and if we find a greatest common factor in our trinomial, sometimes that can make the rest of the factoring process a little bit easier. So what we want to do is first always look for the greatest common factor of the terms in the polynomial. If there is one, then we can divide that greatest common factor from each term. Here are a few examples. Negative 36x cubed and 28x have what greatest common factor? Both 36 and 28 can be divided by 4, and x cubed and x to the first can both be divided by an x. So that is the greatest common factor. For 2x to the 6th, 4x to the 5th, and 20x to the 4th, these all have a common factor of 2x to the 4th that we can divide from each term. And lastly, negative 3x cubed y minus 33xy squared plus 6x squared y cubed, these all have a common factor of 3x y. So if you notice, we're looking for what is the largest x, y that they all have in common. So this y is only y to the first, and that means that we can only divide y to the first out of all three of these. Same with x, this is x to the first, and so that's the most we can divide out of the x's as well. So that's our greatest common factor. Now let's use the greatest common factor to actually factor the expression. So negative 14x to the 4th, 21x to the 3rd, and 7. These all have a common factor of 7. There's no x in that last term, so there's no x's that we have in common. So when we divide that 7 out, we have left 2x to the 4th plus 3x cubed plus 1. The greatest common factor in this expression that they all have in common is 4x squared. So we would have left 7x to the 5th when we divide 28x to the 7th by 4x squared. We would be left with 7x to the 5th plus 4x for our 16x cubed divided by 4x squared. And then finally plus 5 down there for that last term. Now, sometimes after you factor out a greatest common factor, or sometimes there is not a greatest common factor, we can factor some of these trinomials into the product of two binomials. The first method of doing that is using trial and error. So one thing to note before we start this is the very first thing you always want to do is look for a greatest common factor, because sometimes you might have a trinomial that has an a value of greater than 1, but when you factor out a greatest common factor, that a term will end up as 1, and then that'll make the trinomial easier to factor, and like the factors that we've already learned without a coefficient there of the x squared. So always look for a greatest common factor first. So if we're trying this method number 1, which is trial and error, the very first thing you have to do is place all of the factors of ax squared in the first position of the two sets of parentheses. So that's here and here. What are all the different ways I can multiply numbers and terms together to get ax squared? Then you're going to take the two possible factors of your c term, which is at the end there. That's usually a constant, but sometimes it has a variable, into the second position. Then you test to see if the solution works, and if it doesn't, you keep trying different combinations of factors until the inner and the outer products add up to b times x. Okay, so let's take a look at a few examples. So 6x squared plus 23x plus 7. Like I said, this is not of the same type of x squared plus bx plus c because we have a coefficient here. Our a value is 1 or greater than 1. So this doesn't fit the same rule we learned previously where what two numbers multiply together to give you c but add together to give you bx. It's a little bit more complicated when you have a coefficient of something other than 1 at the front. So first we want to look for our greatest common factor. 23 and 7 are both prime numbers. They have no common factors. And so now we will just use our trial and error method to try to find the product of two binomials. So for this first example, here is how we need to work this. So we need to look at the possible factors of 6x squared. I just had 6 there, but 6x squared. So the different ways to multiply numbers together to get 6 are 1 and 6 and 2 and 3. And then we need to also combine that with our factors of 7. So 7 is only 1 times 7, which is nice because there aren't that many factors, but we need to combine all possible combinations of those factors and see what the middle term is going to be. So for example, we have 1x and 6x placed in the first position and then 1 times 7 placed in the second position. And to see if that works, we know that that's going to be 6x squared and that's going to be 7, but what we need to try to find is the middle term of 23. So we're going to have a 7x from x times 7 and a 6x from 1 times 6x, but that only adds up to 13, so that's no good. I'm going to keep the x and the 6x in that first position, but I'm going to flip-flop the 1 and the 7, because now my middle term is going to be x times 1, which is 1x, and 7 times 6, which is 42, and 1 plus 42 is 43, which again is still no good. Now that I've tried all my possible combinations with 1 and 6, I'm going to now try 2 and 3 with my 1s and 7s. So I put 2x first and 3x second, and then I placed 1 and then 7 in that order. We obviously know that that's going to give us the 6x squared, and then 1 times 7 is going to give us 7. We just need to find that middle term. So 2 times 7 is 14, and 1 times 3 is 3. 14 plus 3 is 17, which is no good. And so last chance is I'm going to flip-flop that 1 and the 7, and then check to make sure that will work. 2 times 1 is 2, and 7 times 3 is 21. And 2 plus 21 is 23, so this is our product of binomials. You may get lucky and you may test that one first and find it right on your first try, or you may get unlucky and it can be your last try. Once you get better at trial and error, you will be able to kind of eliminate some possibilities right off the bat. It takes some practice to do trial and error without having to list every single possibility. So let's try another one. 2a squared minus 5a plus 2. Again, number one is to always look for a greatest common factor. We don't have any because 5 doesn't divide by 2 evenly. So now we're going to look at all of our combinations of 2 and 2. These ones don't have very many possible combinations, so it won't take that long to get to the right choice. So obviously the only way to equal 2 is by multiplying 1 times 2. So if I place 1a and 2a in the right spots, then all I have to do is flip-flop the 1 and the 2 in the second position and find which one will work. So 1a times a minus 2, that's a minus 2, and then a minus 1 times a 2 is another minus 2, so that's minus 4a, which doesn't work. So if I flip-flop the second term in the binomials, we will now have negative 1a and then minus 4a, which is going to give us a minus 5a. So this is our answer. Again, looking for a greatest common factor here, we don't have any. With a number like 7, 7 only has 2 possible factors, which is nice, but 8 has the most that we've seen so far, or I guess the same amount as 6 does, but the problem here now is that this is a minus. So we have now double the total possibilities because we have to factor in which of the 2 factors for 8 is going to be negative, and that will change our answer. So you can see this has 1, 2, 3, 4, 5, 6, 7, 8 possibilities just to find the correct answer. So it's nice that 7 is only one possible set of factors, because if this was another number that had more than one set of factors, then my number of possibilities would double or triple. So finding a place to start, what 2 numbers multiply together to give me -8. So -1 and 8, 1 and -8. And then again, the order of that matters in combination with these 1 and the 7, so I have to reverse all that. -8 first, 1 second, +8, -1. And then I need to redo all of that with -4 and +2, and +4 and -2, and then reverse the orders. So you can see all of my different combinations. I just happen to choose 1x and 7x to go in that order. Again, it doesn't really matter which way you place the first one. Initially, I choose to keep the first one the same and reverse the second one. That's just my strategies. You could keep the second ones where they are and flip-flop the first ones, and it would do the same thing. But looking at all of these possibilities, this is the one that gives us that -26 in the middle, so that is our answer. Here's a few for you to try using the trial and error method. This one is one where we do actually have a greatest common factor. So I've been saying this, but we haven't seen one. So I wanted to show you one that does have one. So 4n cubed, 2n squared, and 6n, these can all be divided by 2n to start. So then when I do that, I end up with 2n squared plus 1n, and then -3. And so what I want to factor is this trinomial inside. And so the ones that I want to look for are the factors of 2 and the factors of -3. So rather than doing 4 and -6, we're going to do 2 and -3, which have fewer factors. So that is the reason why we want to look for that greatest common factor first, because doing that reduces the number of factors that we have. So once I factor out that 2n, here are all of my possibilities now with 2 and -3. So again, just with that, making that a negative, it doubles the possibilities, because we need to not only reverse the order, but also reverse the signs. And we want to get which one is going to give me a +1n in the middle, and that's this last combination. Notice you need to keep that greatest common factor in front, because we did factor that out, but it is part of the value. So we can't get rid of it, but when we're testing the possibilities, we can ignore it for the purposes of trying to find that trinomial there that was left after I factored that out.